is today we're going to talk about graphing systems from standard form. Okay? Hopefully most of you guys remember that before the break we were working on graphing systems, which is where we graph two lines on the same graph, right? And we were looking at where they cross to determine what the solution was, right? And the point where they cross, that was the solution. Okay? So if we look at this first one, this one's not in slope-intercept form. Neither of these are in slope-intercept form, right? So if neither of the equations are in slope-intercept form, what you guys are going to have to do is you're going to have to use a different method to graph, okay? You can either graph from standard form using the cover-up and solve method, right, where we cover up each variable to find the x and y intercept and then solve it. Okay, and then put those two intercepts on the graph and graph them, okay? Or what we can do is we can solve each equation for y and then graph it like that from slope-intercept form, okay? So I'm going to show you an example of each method, and then we're going to do some practice problems together that we're going to then put in your notebook when you guys get them back, okay? All right. So let's take a look at this first one. If I were to use the cover up and solve method for the first equation, here's the first equation, right? Does it work out nice? Like, are they nice numbers to work with? Am I going to get fractions if I cover and solve? No, I'll get regular numbers, right? So if I cover up the x or I cover up the y and I solve for either of those, it's going to work out to give me a pretty nice number. So when I cover up and find the x-intercept, what is the x-intercept of this first equation? -2, right? So x equals -2. Okay, what happens if I cover up and I solve for y here? Well, I get negative y equals -2, so what's positive y then? Yeah, +2, because I have to divide both sides by -1, right? So now that I have both of my intercepts, I can go ahead and graph them. So x equals -2 is right here on the x-axis. Y equals +2 is up here. Okay, and then what I can do is I can use a ruler to go ahead and connect my two lines. Okay, or my two dots with a line, rather. Okay, so there's my first line. All right, so now this is equation number 1 that I've just done. Okay, let's now take a look at equation number 2. All right. So the second equation is this one right here. Now, if I'm going to cover up and solve and cover up and solve, it's going to work out pretty nice in the second one also. Okay? So let's take a look at the numbers that I get for the second one. Okay, for the second one, my equation is x minus 4y equals 4. So when I cover up to find the x-intercept, what is the x-intercept? 4, right? Okay. Now, when I cover up and solve to find the y-intercept, here's what I get. -4y equals 4. Well, if -4y equals 4, how do I solve for y here? Yeah, divide by -4. So what is the y-intercept then? What kind of one? -1. Okay. So now I can take these two intercepts and graph them. So x equals +4 is over here, and y equals -1 is over here. Okay? Now, I'm going to go ahead and connect those dots. Let me be a little more precise here. There we go. Okay? So here's my second line. All right, and I've now graphed my second line, and now can I see where the two lines are intersecting? Yeah, right here. So remember, this point of intersection, this is actually the answer. So what is the actual answer? -4, -2, right? So my solution, -4, -2, this is actually the final answer. Okay? All right, so does that make sense what I did there when I was solving? Is my remote not working? What the heck? Okay, the cover and solve method works really well as long as like this number goes into this number evenly, right? Okay, but what happens when one of these numbers doesn't go into the number over here very easily? I get a fraction, right? And I can estimate where that fraction is to help me graph. Okay, or what I can do is I can just take that equation and solve it for y. So I'm going to show you guys a slightly different method in this one. The equation that's easy to cover up and solve to find the intercept, I'm going to do it that way. But this second equation, because when I cover and solve here, I get a fraction. What I'm going to do is I'm going to show you guys how to solve this one for y and then graph it. Okay? All right, so let's take a look at this one right here. Okay? For the first equation, I'm going to rewrite this, x minus 2y equals 4. Okay? When we cover up, what do we get for our x-intercept here? 4. Okay? What do I get for the y-intercept? Well, I get negative 2y equals 4, so how do I solve that? Divide by what? Negative 2, okay? So when I divide by negative 2, I'm going to get y equals negative 2 for my y-intercept, right? Okay, so let's go ahead and put each of these onto the graph. So x equals positive 4 goes right here, thank you. Okay, and y equals negative 2 goes right here. Okay, so now we can go ahead and connect these, right? That one was easy. Okay, the next one, however, when I go to graph this next one, it's 3x plus 2y equals 4. I see that if I'm going to try to use this cover-up method, I'm going to get a fraction. Which I could get a fraction and estimate where that is, but you guys don't really care for fractions much, right? So, one thing that you can do so you don't end up with fractions is just solve this equation for y. So if we're going to solve this equation for y, here's what you guys can do. Okay? Draw your line through the equal sign. We're going to do the same thing to both sides. So, what needs to go away from this side if I'm solving for y? The 3x, right? So let's subtract 3x from both sides. Okay, I want to write this in slope-intercept form, so I'm going to write the 3x first. And the regular number, the 4, was a positive, so it's plus 4. Okay, now, how do I continue solving this for y? Yeah, divide all the parts by 2. Every single part. Okay, so now here's what I get. Y equals negative 3 halves x. What does that make there? 4 divided by 2? 2. Okay? So now, what is your y-intercept? 2. So let's put our y-intercept on the graph. What is your slope? Down 3 to the right 2. So down 1, 2, 3 to the right 1, 2. Down 1, 2, 3 to the right 1, 2. Okay? So now that we've got that, now let's go ahead and connect, and can you guys see where your two lines intersect? Okay, so what is the actual answer here? This is the actual answer, so what is the actual answer? 2, negative 1. Okay, that's the actual answer. All right, now we learned about graphing systems before the break. All of the systems we graphed before the break were all given to you guys in slope-intercept form. Okay, all the ones I'm going to give you guys today are going to be in standard form. So you're either going to be doing the cover up and solve, or solving it for y and using it from slope-intercept form to help you graph. Okay, we're going to practice a couple together. So right now I'm going to give you a graph paper so you can practice with me. Okay, so the piece of graph paper I just gave you, you're going to do some examples on here. Okay, eventually it's going to get saved and it's going to go into your notebook, so don't throw it away. Okay, if you want, you can title the top of this Graphing Systems in Standard Form. Okay. Okay, so let's take a look at the first example that I'm going to have you guys do with me to practice. Okay, so here's example number 1. Let's try this one together. Okay, so go ahead and write down your 2 different equations that you have there. All right, so if I look at the first equation, is that one going to be easy if I use the cover and solve method? Look, do those numbers divide into each other easily for the first equation? And then that? Yeah, okay. So if I'm looking at this first equation, and I'm going to cover up and solve, I'm just going to rewrite this one over here so I can work with it a little bit. Okay. All right, when I cover up and solve for x, I get 2x equals -4, right? So what do I get for my x-intercept? What's the x-intercept there? What kind of 2? -2, right? Okay, then if I cover up and solve for y, well, there's nothing really to solve because y is already by itself, right? So what do we get? We just get y equals -4, right? So here I have my 2 intercepts, right? I have my x-intercept and I have my y-intercept, okay? So let's go ahead and I can draw a graph to help me graph those 2 intercepts. Okay, and now let's go ahead and put my x-intercept and my y-intercept onto the graph. So my x-intercept is at -2. So I can go ahead and put that one over here. And my y-intercept is at -4. 1, 2, 3, 4. And then you guys can go ahead and connect that with your ruler, right? Now try to be really precise when you're connecting here, going exactly through the points. Okay, so there's your first line. Okay, does anyone need more time getting that down for the first one? Okay, so now I've already done the first one. Now let's take a look at the second one. So the second one is this one right here. Okay, if I'm going to cover up and solve the second one, what do I get for my x-intercept there? 4. That one's pretty easy, right? Now, if I cover up and solve the second one, I get 2y equals 4. So what is my y-intercept for that one? Yeah, it's 2, okay? All right, so let's go ahead and graph those 2 intercepts. I have my x-intercept and I have my y-intercept, so I'm going to graph each of those. So on the x-axis, I'm going to go over to +4, so 1, 2, 3, 4. And on my y-axis, I'm going to go up to +2, 1, 2. Okay. All right, so now let's go ahead and connect those 2 points. Try to be really precise. Make sure you go exactly through where each of those points is. Okay, So are you guys seeing where they're crossing? Yeah. Okay. So what is this location where these 2 points are crossing? It's right here. Okay, so what is that ordered pair? Negative 1, 2, 3, 4, up 1, 2, 3, 4. So that location is negative 4, comma, positive 4. Okay, and there's your solution. Now, what were to happen if the two lines never crossed? Like, say they were going parallel. What would you write down? No solution, right? Okay. What would happen if you graphed them and they ended up being the same exact line? What would you then write? Infinite solutions, right? Infinitely many. Okay. So we only get one solution when they cross, and the one solution is the point where they cross. But sometimes if they don't cross, then that means it's no solution, right? And if they are the same line and they're on top of each other, that means it's infinite solutions. Okay. All right. Does everyone have that one written down? Okay. All right. So let's take a look at a second example. Can I move this out of the way? Are you guys good? Yeah? Okay. All right. So let's have you guys all write down. Here's example number 2. Okay. And here are your 2 equations. Okay, so let's take a look at the first equation. If I do this cover up and solve on the first one, is 3 going to go into 4 evenly? Okay, and if I do it here, 4 goes into 4 evenly, but the problem is I'm getting a fraction when I do this one, right? So if you guys want, you can do it that way, and you can have a fractional intercept, and you can estimate that. Okay, or what you can do is you can rewrite this equation and you can solve it for y, which is what I'm going to do. So down here, what I'm going to do is I'm going to rewrite this equation and solve it for y. Okay, so to solve this equation for y, what do I need to get rid of from this side? The 3x. Let's subtract it because it is positive. Okay, now this 4y is a negative, so I'm going to drop that down. I'm going to write the 3x first because I want to write it in slope-intercept form. What sign was the 3x? Negative. So make sure you write the negative in front of it. What sign was the 4? Negative, so it's a negative or a minus 4, right? I should not have a plus here, not a plus, okay? All right. So now how do I continue to isolate y? Yeah, this 4 is multiplying. Let's divide by that negative 4. We're going to divide all of the parts. Okay. So here's what we get when we solve for y. Y equals, what's a negative divided by a negative over here? Positive 3/4 x. And what's a negative 4 divided by a negative 4? Positive 1, so right, plus 1. Okay, does that make sense what we did there? Okay, so now we've got our first equation written in slope-intercept form. So let's go ahead and draw my xy axis, and then let's graph this one. Okay, so what's your y-intercept on this one? Positive 1. So let's put positive 1 onto the y-axis right there. Okay, what is your slope? rise 3, run 4. So remember, we always run to the right. So up 1, 2, 3, run 1, 2, 3, 4. You can do that again. Up 1, 2, 3, run 1, 2, 3, 4. You could also go backwards, going down and to the left after you've gone the correct way in the beginning. Does that make sense? Okay. So there's a bunch of points from my slope. Now I can connect them. All right, so we've got our first line. Do you guys need some time catching up? Or are you guys okay? You're okay? All right, so now let's take a look at the second line. Okay, for the second line, I'm going to rewrite it down here. Okay, so this one, I'm rewriting it. Okay, does this one work nice for the cover-up method? Yeah. It does, right? Now, even though it works nice for the cover-up method, if I'm going to cover up and solve this, what do I get for my x-intercept? -12. Now, I could use the cover-up solve method, but wouldn't my graph have to be really big here? Like, I would have to graph -12. -12 would be way over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I mean, I could do that, right? And I would get my x-intercept way over here, which is okay if I want to draw a super big graph. Does that make sense? Okay, but if you guys don't want to make your graph super duper huge, okay, like maybe one of the problems you get tonight, it has like your x-intercept is -20. Do you really want to make your graph that big? Maybe what you might want to do is you can still solve this one for y and then graph it using slope-intercept form. Does that make sense? Okay, so you can do this one either way you'd like. You can use the cover up and solve method. I mean, I could fit this x-intercept on here, it would just be way over here. Or I can just solve this for y really quickly. Okay, so I'm going to solve this for y really quickly. So I'm going to subtract x from both sides. So I get 4y equals -x minus 12. And then what do I need to do to solve for y? Yeah, divide by 4 to all the parts, right? Now remember, when you don't have a number up here in the numerator next to x, what number is really there? 1, -1, right? So just assume like there's a -1 there, and so for our final equation, we're going to have y equals -1/4 x minus 3. Is everyone following how we got that? Okay, so now let's go ahead and graph this. Okay, my y-intercept is -3, so go down to -3. My slope is down 1, right 4. Down 1, right 1, 2, 3, 4. Down 1, right 1, 2, 3, 4. Now, after I go down and to the right, because I always run to the right, I can do some opposite direction points, right? So now I can continue the pattern in the opposite way, so up and to the left, and up and to the left. Okay? So here's what your line looks like. Okay, now here's your intersection point. So what is your actual solution? -4, -2. Okay. All right, are there questions on how we did that one? Okay, I'm going to give you guys one more that I want you to practice like either on your own or you can work in your groups to try to solve this last one. And then I'm going to have you guys check your work with me and see if you guys got the same thing. Okay? All right, so flip over to the back of your page if you need to. Does anyone need more time catching up on this before I turn my page over? Okay, All right, so here's your last example that I want you guys to try to do either on your own or in your groups. Okay. Okay. So go ahead and give that one a try. Okay, so let's take a look at what the solution should have looked like. Okay. All right, so put your eyes on the board. Okay, here's what your solution hopefully should have looked like. Okay, when you solved the first equation for y, okay, if you did it that way, you would have got y equals negative 1 over 4x plus 3. So your x-intercept was 3, and you're going down 1 to the right 4. Down 1 to the right 4. Okay? Then if you solve the second equation for y, you should have got y equals 3/2 x minus 4. It should have been a minus 4 because 8 divided by negative 2 should have made a minus or negative 4. Okay? So then that gives you your y-intercept of negative 4, going up 3 to the right 2, up 3 to the right 2. And then you can see where your intersection is. Raise your hand if you got your intersection point there at 4, 2. Okay, a lot of you. Okay, good. All right, so this is what you're doing today for the homework. Are there questions on this? On how to do this? Okay, this paper that we just did, do not throw it away. This is going into your notebook, okay? I don't have your notebooks ready to give back to you guys yet, so just hang on to this paper. Put it in a safe spot. Do not throw it away, okay? All right, for homework tonight, I need you guys to copy down these problems. You may take a picture of it, okay? And then you're going to complete these. I'm going to give you a piece of graph paper to do these problems on, okay? So you have a piece. So that's what you're working on until the end of the period, okay?